Hello everyone, my name is Alden, this is the Blank Script, and this is also my explainer video for my physics class in college because even us cartoon characters need a proper education. So what I'm attempting to do in this is explain how I got the acceleration, how I got the magnitude of the acceleration, how I got the forces acting on the system, and how I got the magnitude of the forces. So the first thing I did was I went to the tutoring center to ask for help, because if you think that your calculations might not be correct, you should get that checked out, even if it is just a small thing, a small stupid little thing you don't think is really important. You should ask for somebody else's eyes on that, because that small little thing could turn into a really big thing like it did with mine. Because I did make a mistake. I'm not going to tell you what that mistake was, but I did make one, and it was pretty small, but it could have turned into something much bigger and I would have gotten the wrong answers. So, once I went to the tutoring center and tutor Shay, thank you Shay, was looking over me as I worked on this, pointing out every little mistake that I made. We started with the acceleration, as one would do in a scenario where you start with the acceleration. In a scenario similar to this, you would need to use the centripetal acceleration and the tangential acceleration as component vectors to find the actual acceleration. However, in this specific scenario, the velocity isn't changing. And that means there is no tangential acceleration, meaning the centripetal acceleration is the only acceleration that matters. And in fact, it's the actual acceleration of the bike. Therefore, it's correct just putting down the centripetal acceleration. And as you can see, this is a person on a bike in a hamster wheel. It's a circle. So the next thing we have to do is find the acceleration magnitude. And I did this by using the equation that we are supposed to use. What, you don't know the equation? Well, neither did I. I looked it up on Google. Little tip for you, use Google if you're not sure. Or like me, you are sure because you have it written down somewhere, but you're too lazy to go look for it. That equation, as you can see right beside my fat head, is velocity squared divided by radius, or in this case, 8 meters per second squared divided by 7 meters, which is equal to 9.14 meters per second squared. Next, as you can see by this other picture, we need to find the other forces acting on the system. And this includes, but is not limited to, actually it is limited to these because they're the only forces acting on the system, gravity, static friction, and the normal force. Gravity is the first one we're going to tackle, as that's just the mass of the object times the gravitational acceleration, which is 9.81, and as you can see, it comes out to 588.6 kilogram meters per second squared, or newtons, as a normal person would say. The next is the static friction, but we need the normal force, so we're going to skip that and go straight to the normal force. Under ordinary circumstances, the normal force is equal to gravity, but in the opposite direction. But this isn't normal. This is a different scenario. A scenario where the ground is actually 35 degrees from horizontal, which means you need to use cosine in order to figure out what the actual magnitude is, because it's not straight up and down. So we plug cosine of theta, or cosine of 35 degrees, into the calculator, and boom, 482.2 newtons. Then we can plug that into the static friction, and we get 482.2 newtons times the static coefficient, 0.9, which equals 434.0, not exactly, because I rounded. And in case you were wondering, I managed to get the force vector line things by saying, gravity is always down, the normal force is always opposite the direction of the ground that the object is touching, and the static friction is always in the opposite direction that the thing is moving. And by thing I mean object. Alright, well, I guess that wraps up this poorly explained explainer video. I hope you enjoyed, or at least laughed, because, you know, that's kind of the point of my entire channel. Like if you liked, dislike if you disliked. Don't worry about subscribing because I haven't done anything yet. Because I haven't really done anything yet. I can't really ask you to subscribe to a channel that hasn't really done anything. And come back if you feel like it. You know? It's chill. We chill. Later.